Hi, we're at SMTConnect in Nuremberg 2023. I'm joined by David Greenman from Humiseal. Good to see you again.
And you, Ian. And you.
Interesting show. I mean, it's things are getting back to normal kind of thing. It's nice to see people wandering around. And it's funny talking to people. It's interesting how the industry has been changing, and actually, conformal coating is one of the areas that has changed an awful lot over the past few years. So talk me through where Humiseal's at the moment.
Okay, so let's look a little bit at history. In 20 odd years ago, we had axial components, round components, large conductor spacing, wide track widths and gaps.
The good old days.
The good old days. Now we have surface mount, increased packing densities, reduced track spacing, reduced track widths. It's really getting quite hard. We've also got, of course, surface mount components, and you've got your resistors and capacitors that are square edged, and that is the difficulty in coating. So Humiseal have been working on developing new products to address the problems of sharp edge coverage.
Because inevitably that coating will get thinner on a sharp edge.
Absolutely. It's you can't with a traditional coating, conformal coating, you cannot defy gravity.
Yeah.
Gravity will pull it off. And of course, your surface energy of your board, if that's poor, that doesn't help. It causes lots of different problems. A capillary action, which can draw the coating away from the surface of the components or underneath. So what we've been doing is looking at how we can develop a coating that is going to overcome the sharp edge coverage. We've been doing this for the last couple of years, and we believe we've found a solution.
Right.
We currently have two products that are out there in beta testing. One is a synthetic rubber.
Right.
The other is a polyurethane. Both conventional solvent-based at the moment. The reason we chose solvent-based is because they're the easiest ones to adapt to this problem. In development will be a UV curable 100% solids, and when that comes out, then that solves the problem of solvents, although we're using solvents that are currently acceptable to the market. So we've been testing this, and the way we've been testing this is to immerse a board in a beaker of salt water, equivalent to seawater, and we power that board up. Now, if you pop in a uncoated board and you power it up, immediately you're getting a chemical reaction, bubbling, and potential dendritic growth and corrosion. So with our new coatings, you can immerse it in the beaker, power it up, and you look at your power supply, you've got 24 volts there, zero current. With your uncoated board, 24 volts, but you're drawing any range of current from it. So that's how we're developing it, and we are seeking beta sites. The product is unique. It's not the same as a conventional coating. It doesn't go down the same. At the moment, it can only be spray coated by either a robotic spray system or a hand spray system. We're looking forward to develop further products for film coating application to gradually replace the products that are out there that are going on the film systems.
Fantastic. I mean, that it's only going to get bigger, the demands for this, isn't it? Because, like you say, components are getting what's getting packed on a board is more and more all the time.
It's more compact. They're getting smaller, and in fact, we've seen with some clients that have come to us with problems that thin edge coverage on some coatings they got dendritic growth literally across the surface of the coating from one edge of a component to the other sharp edge.
Yeah.
That's what pushed us into looking at
Yeah.
this problem and developing something to overcome it.
And how long did you say it's taken?
We've been looking at this for 2 years.
That's pretty quick, really, isn't it? I mean, because
We have a very good R&D team in the United Kingdom, in Winnersh, that work very well on these sort of projects.
And response to this must be pretty keen, I'd have thought.
We haven't fully released the product yet. As I say, we're looking for beta sites to test it, where we would send in one of our tech support guys to assist in the application, because it is different.
Right.
It is different, and it's different in application. So you need that tech support to get it right.
Yeah. So it's a bit of a change to align for people, and it's a slightly different way of thinking as well as... Yeah. But applications for this in defence, aerospace and electric vehicles, they're crying out for this.
Oh, absolutely. I mean, those are the markets that obviously we're looking at, we're approaching, but also white goods. There's a few companies out there that are concerned about their control boards in various bits of equipment getting condensation on them, and if you get a film of condensation and you've got poor sharp edge coverage, then you can get, and you've got no clean, which I think we'll be talking about that in another episode. If you've got no clean, then you've got the chance of dendrites growing, and that's again, as I say, we've seen them across the surface of coatings.
On a personal level, you've been in the industry for a long time. What are the most rewarding parts for you? Is it the science? Is it the economics of making businesses run more efficiently? Because this all feeds. This also feeds into a lot. We're talking about sustainability, all these sort of things. If you've got more reliable coatings, then you don't have reworks, you don't have failures.
I think one of the things that's driving this is the drive to have repairability, to have longer lifespan of products. So from my personal point of view, what I've enjoyed over the years is solving people's problems on reliability, on people putting their boards in harsh environments. If you think, again, boards now go into environments that we wouldn't have thought of 30 years ago. When we started out in this industry, it was primarily military and aerospace. Now, it covers virtually everything from, whiz-bang weapons, as I call them, to phones, to mobile phones, tablets. They're all got most of them have coatings on somewhere. So, it's been a long journey.
Yeah, but it's still a cutting edge, isn't it?
Oh God, yeah. Well, if you don't keep up with it, eventually you're just going to disappear off the surface. So.
And competition is getting fiercer now, and demands for solutions more quickly.
Absolutely.
So, Well, thanks for spending time to talk about those.
My pleasure, as always.
Thank you, David.
Thank you.